So our next section, we are continuing with completing the square, and this time we have a lead coefficient that is not 1. So our first example, we've got 4x squared equals 4 minus 12x. Now the first two steps that I wrote for you off to the right are interchangeable. You can do these in either order. We're used to getting the two terms of the variable all alone. You still can do that first, but what I like to do is get rid of the coefficient. So we do that by dividing everything by a, meaning the coefficient in front of your x squared. So in this case, we're going to divide everything by 4. And then we're going to complete the square like normal. So all of these steps are the same steps that you saw in the previous lesson. So we're going to get our two terms with an x on one side of the equal sign. And then remember, the process for completing the square is we first start by dividing our b term by 2. b, remember, is the coefficient of your x term. So in this case, that is 3. So we're going to cut 3 in half. And then square it and add it to both sides. Sorry, that was the whole process of completing the square. And then we're going to factor. So what I'm going to do is I'm first going to factor, and then I'm going to remind you why these two expressions are equivalent. So on the left-hand side, we forced this to be what's called a perfect square trinomial. So we factor it as x plus 3 halves squared. And then on the right hand, 3 halves squared is 9 fourths. So I'm going to convert 1 to 4 fourths. I'm going to show my work here in case I lose some of you. Because we need a common denominator before we add our fractions. So we end up with 13 fourths. So before I finish solving, I'm going to make my problem a little simpler by getting rid of the fractions and remind you what it means to square something. Remember, it means multiply it by itself. So the x times x would give us the x squared. X times 3 and 3 times x, we would have 3x twice. And then the 3 times 3 gives us, I'm going to leave it as a 3 squared because I want you to see the pattern that we created right here and how that will match the pattern that we get when we square a binomial. So I'm going to finish this pattern, and the last thing that I'm going to do is rewrite this, instead of as 6x, as 2 times 3x, because it's equivalent. Anytime you square a binomial, those two terms in the middle will be identical. You will get 2 of exactly the same thing. So that's why when we complete the square, we start by dividing b in half. And then that piece that we find right here, I'm looking over in the left-hand column, is what we square and add it to both sides. So I'm hoping that you see this pattern. I'll continue trying to remind you where it comes from. But remember, this expression right here came from the factored form quantity x plus 3 squared. So this is what's called a perfect square trinomial because it fits this pattern of x squared plus 2 times 3x plus 3 squared. And we had that same pattern. We forced it into that same pattern with this one that we're solving here. All right, so let's finish solving. We have to undo that square, so I'm going to take the square root of both sides. Now what's nice about taking the square root of a fraction is that you can square root the numerator and the denominator separately. And my denominator happens to be a perfect square, so that means I don't have to rationalize the denominator. And then I'm going to subtract that 3 halves from both sides. And that's a 13 under the radical. It didn't turn out real clear. All right, let's look at a couple more. That's all we're learning today, so we're just going to continue practicing this same concept. All right, so I'm going to start by dividing everything by the leading coefficient. So in this case, my lead coefficient is a -2. So I'm going to divide everything, including my 0, by -2. But of course, that doesn't change my 0. I just want to make sure that I emphasize that so that if there is a term on the other side, you divide that by the -2 as well. All right, so then we complete the square. Actually, sorry, we isolate our two terms with an x first, so I'm gonna add that 2 over, and then we will complete our square. So we're gonna cut the b value in half, and that piece that's sitting right here is what we will add to both sides of the equation. Gotta keep it balanced. And since this one's not a fraction, I'm gonna remind you where this comes from. So we're gonna factor this in a minute to x minus 4 quantity squared, which means x minus 4 times itself. So if I multiply that out, I'm going to get the x squared minus 4x, or 2 times that 4x. And then the minus 4 squared will be a positive 4 squared. So notice how this expression that I have right here matches exactly this pattern. We forced it to be a perfect square trinomial so that we could factor it as x minus 4 quantity squared. So once you complete the square, I don't want you thinking about the factoring, I just want you to factor it. The x drops down, this sign drops down, and the 4 drops down. To finish solving, we're going to take the square root. Perfect square factor of 18 is 9, so I'm going to pull that out as a 3 and add 4 to both sides.